Studies Corner, we're going to look at multiplying and dividing rational expressions. A rational expression is a ratio or a fraction of two polynomial expressions. So in these first two examples, we're going to simplify. So what that means is I'm going to pull apart my numerator and pull apart my denominator and see if there's anything I can cancel that's the same. So let's look at number one. I have 5x. Now we're going to factor, right? X plus 3 and x plus 1. On the bottom, I'm going to rewrite x minus 6. And then I have x squared minus 9, which is a difference of two squares. So I can factor that to x plus 3 and x minus 3. Now from here, what is exactly the same? This x plus 3 and x plus 3 is exactly the same. There's nothing else that I can simplify. So I'm going to get 5x times the quantity of x plus 1 all over x minus 6 times x minus 3. All right, let's look at number 2. Okay, there's nothing I can really do at the top except for this one does have a greatest common factor. So I'm going to factor out a w, and I'm left with 4w minus 3y times w plus y. Now, if I notice on my denominator, I have something that's pretty similar. This right here, this binomial is similar to this, except for, first of all, I have them in an opposite order. So let's take care of that first to see if that's going to help me. So I'm just going to switch that around. I'm going to put my w first. Now, again, that negative comes with it. And I have 5w plus y. Now, when I do that, I notice this binomial and this binomial are the same except for their signs. So in order to kind of fix that, I like my leading coefficient to be positive, right? So I'm going to rewrite my numerator. My denominator, I'm going to factor out a negative 1. And then I'm left with 4w minus 3y. And again, I rewrite 5w plus y. From here, now I can see these binomials are exactly the same. So now I'm going to simplify. This negative, I'm actually going to kind of move up, right? W divided by negative 1 gives me negative w, multiplied by the quantity of y plus w plus y all over the quantity of 5w plus y. So there's my final answer right there. All right, moving on to number 3, it says, for what values is the rational expression undefined? So remember, something is undefined is when I have a number on my numerator and a 0 on my denominator. That is undefined. So what this question is asking is I need to look at my denominator to figure out what values are going to make that 0 on the bottom. So what I'm going to do is I'm going to factor this first, right? Pull everything apart. X and X signs are the same. I get 2 and 4. So I need to set 4x is equal to 0, x plus 2 is equal to 0, and x plus 4 is equal to 0. That's going to help me get my answer because of that 0 product property. So my final answers are x is equal to 0, x is equal to negative 2, and x is equal to negative 4 when I solve for x. All of those values would give me a 0 on your denominator, which would make that rational expression undefined. All right, moving on. We're going to simplify some expressions here. Now, there's a number of ways you can do that. You can simplify the numbers first. You can multiply across first. And I do them differently, really just depending on what the values are. So I'm first going to simplify this 12 and 21. I know they're both divisible by 3. So that's going to give me a 4 here and a 7 there. I also noticed too, I can kind of keep going if I want, the 7 and 14, that gives me a 1, and that gives me a 2. And I can keep going with the 4, that 4 goes into 4 once and into 8 twice. So I can do all of that. A couple different ways. You could just multiply across and simplify at the end. Okay, so when I multiply my numerator across, I get 2. Now I'm going to put the letters in the variables in alphabetical order. A squared b, c to the third, d to the second. My denominator is a 2 again, and then I have a to the first, b to the first, c to the second, and d. Now, when I simplify those, 2 over 2, that simplifies to 1. A squared over a gives me a. The b's will simplify to 1, and I'm left with a c to the first on my numerator and a d to the first on my numerator. So actually, that is my final answer there, a times c times d, a, c, d. Okay, let's move on to number 5. Now, in this one, we're multiplying. So remember, you multiply by the reciprocal. Just like you did probably in middle school or maybe 5th grade with regular fractions, the rules are the same. Okay, so I'm going to rewrite. Now, first, I'm going to simplify my, my coefficients here, my first one. I know they're both divisible by 4, so this is going to give me 3 here, and that's going to give me 10 there. Sometimes I just like to simplify those right away, so I'm not dealing with really big numbers. And I'm just going to rewrite the rest. So this division sign becomes multiplication. Now I can do the same thing. I can see 6 and 16, they're both divisible by 2, so this gives me 8 and this gives me 3. So now my numerator here is going to become my denominator and vice versa, and I get 8a to the second x. Okay, now from here, I can just multiply my numerators across, right? So 3 times 8 gives me 24. I'm going to put things in alphabetical order. So I have a to the second, x to the fifth, y to the second, all over 30, a to the fourth, b to the fourth, x to the second, y to the second. Okay, so from here, I can simplify. 24 over 30, that simplifies to 4/5, right? They're both divisible by 6. A to the second over a to the fourth gives me a to the second in my denominator. And then I have b to the fourth on the denominator. I don't have any b's in my numerator. X to the fifth over x to the second leaves me with x to the third on the top. And then my y's to the second, they will simplify away. Okay, so there's my final answer right there. All right, moving on. Number 6 is multiplying. Now, again, remember we talked about I have to pull everything apart and then see what I can cross off. So I'm going to do a lot of factoring in this one. So my signs are the same. I'm sorry, the signs are opposite. Factors of 16 that when I subtract, I get to 6 is going to be 8 and 2. So my 8 goes here, my 2 goes here. My denominator, I'm going to factor that to x minus 8 and x minus 8 times, I have an x minus 8 on the top. And the bottom will factor to x plus 3 times x plus 2. Okay, now I have to cross cancel. So I have 1x minus 8 here and 1 there. So you have to go 1 for 1. I'm able to cross off my other x minus 8 because I do have 1 as a numerator and 1 as a denominator. My x plus 2 can simplify. And so I'm really left with a 1 on the top over x plus 3. All right, looking at number 7, remember this right here, that's division. So it's similar to this problem in number 5 that we have, but it's just written differently. So again, I'm going to start to pull things apart. So my numerator right here, this gives me x plus y and x minus y, right? It's a difference of 2 squares, a perfect square minus a perfect square. Same thing on the bottom, y plus 7 and y minus 7. Now I'm going to change that division to multiplication. So my denominator becomes my numerator, and my numerator becomes my denominator. Now again, I start to notice things. So I can simplify my y plus 7. And I notice that if I were to factor out this -1, right, we always want our leading coefficient to be positive, that I can then cross off my x minus 1 and x minus 1. Okay, so I am left with my numerator is x plus y. My denominator is y minus 7, and this -1 I'm going to put right in front of my fraction bar. Okay, that's it. Great job today, and you have a good day. Thanks for stopping by.